Hello everyone. This is Dr. Rachita Mishra speaking to all of you. So today in our class of software engineering, we will be dealing with analysis modeling, the second part, and we will be dealing with all the types of behavioral modeling. The topics that we will be covering today is what and why of behavioral modeling. And then we will look into 4 types of diagrams that we do for the behavioral view. Those are state diagram, sequence diagram, collaboration diagram, and activity diagram. Just give me 1 minute. So let's come to the this diagram, which we had shown in the last class. That is the elements of the requirement analysis, which is the part of our requirement engineering. Mainly in the analysis, requirement analysis, the elaboration part of the requirement engineering, we start doing all kinds of modeling, and we have 4 types of elements in this modeling, and these are the set of the diagrams that we use. And today, earlier we have done the structural diagrams, that is class-based and flow-oriented. And today's class, we will be dealing with what I have put in red, the state diagram, sequence diagram, activity, swim lane, and collaboration diagrams. All these together form the behavioral view as it is mentioned in the Unified Modeling Language, the UML. So we will look into some of the concepts, and also we'll try to take up some problems in it. So what is behavioral modeling and why should we do it? So behavioral modeling indicates how the software will respond to external or internal events or anything that comes to the software. Some condition happens, some signal comes, or some other stimuli comes to the system, how it behaves. It may be from the internal, or it may be coming from some external source. And they are also called interaction diagrams. In the UML, they are together known as the interaction diagram, because they display the interaction between the system and the various other external and internal events. And they depict the dynamic character of the system during execution. So when the system will execute, what will be the dynamic character? If you remember, in the class diagram, what we had seen was the static character, the structural character, which doesn't change. But in case of the interaction diagrams or the behavioral diagrams, this is dynamic. We are trying to see what will happen when the system will execute. So in sequence diagram, we depict the exchange of messages between objects, that is the instances of the class, and any user from the user environment, if any external user is also there, then how these objects and the external users, they exchange the messages to satisfy certain objective. In collaboration, what we say, we show the objects linked with messages to satisfy certain operation. And in the state diagram, we try to take the class, the main class, the key classes, and we try to see if these objects they are following certain states. So in certain applications, you will find this very relevant, that the objects stay in a particular states at a different time, depending on what is the condition that has happened to him, what is the previous state and what event came or what message came to them. And accordingly, they will transition from one state to the another state. So that is where we draw the state diagram. Then we have the activity swimlane diagram, which shows the flow of business activity for different roles or different entities, or you can have different objects or class. And we will also see how they are synchronized. And as such, as a synchronized operation, business operation, they will describe a user scenario, the way just like we described the user scenario in terms of use cases. Similarly, using activity and swimlane diagram, we will give the details of the flow of the business activity or a business operation. And why should we do these models? Because these models help in describing how objects and entities will interact and how they will collaborate to satisfy business objectives. So the requirement will become much clearer to us in terms of the functionality, the user functionality. And improved problem understanding will help make efficient design and code. If we have understood the problem, then we will make better design and code. And also it will facilitate the creating of testing scenarios. By looking at these diagrams, we can create the testing scenarios or the test cases very easily. And these will help us validate the software that we have developed. So how we go about with the behavioral modeling? So this is a question which all of you must be thinking, that we have got 4 diagrams, but truly speaking, you may not need all the diagrams. You may need few of them. So what we have to do, we have to evaluate all the use cases which we have created in the very beginning of our requirements engineering. And we have to understand the sequence of interaction within that system. We have to identify the states of objects. So we have to, since we have got the use case, we can identify the objects and class. And we have to see whether the class is remaining in a passive state or an active state. Is it moving from one state to another state? And in that case, if it is moving from different states, then what is the event that is affecting the states? Then we can build the state transition diagram. Then similarly, we will create the sequence of the lower level tasks of each use case. Whenever there is a function or an operation, we will create the lower level tasks. And for those lower level class, we will develop the activity diagram, which is like a control flow of this task. Then we will build the sequence diagram, which will show the collaboration or the messages between message flow. And also we can build the collaboration diagram. Then we can review the behavioral model. So let's look at what is state diagram for the analysis classes. In last class, we have seen how we can identify the classes, and how from the potential classes, we can eliminate some of the classes or merge them and create the analysis classes. So now we are in the requirement analysis phase. So we will take the analysis classes and create the state diagram. Now state diagram has got many names. You can call it by state transition chart or state chart or a state machine. So sometimes don't get confused. People will refer it with different names because it has been in use for a long time and different authors have given different names. It depicts the sequences of the states that a key object or class undergoes. So this is very important, the key object. We don't go for each object, but we go for the key object which often changes the state. So during its lifetime, during the lifetime of the object, what is the responses that when it receives the outside responses, what happens to it? Does it change the state? And if not, it is okay. If it is changing the state, then we have to create a state diagram for it. The state is the set of values that an object holds at a specific point of time. So as you know, the object will have different properties. So that is what it means. In UML, state diagram represent the active states for each class identified in requirement analysis and the events that cause transition. And what are the components for the state diagram? We have states, we have events, we have messages or signals, and we have conditions and constraints. So these conditions and constraints will be defined over the messages. They will actually qualify the messages a little bit more. So how to identify events and states? We will take the use case description, and there the activities that involve actors of the system. So we will take the actors. The use case description will contain the sequence of activities or the dialogue between the system and the actor. So that is our first point. Then when the event occurs, whenever the system or actor exchange information, so that is called as an event. Event is not the information, but the fact that information has been exchanged. Okay, and actors should be identified for each event, and also we have to identify whether they have exchanged any information or not. If they have exchanged any information, was there some condition or the constraint? So that also we will list it. And if this happens, does it move to another state? If the state of the system or its relevant classes will change, then we have to note that. That has to be recognized. And we have to give an assigned name or an identifier to that state. Just like we have given names to the class, similarly, we have to give name to the state, because now the class is in a different state. So let's look at some of the states. What is actually states? So state can be active, it can be passive. As I told you, it is something like a property of the class. So passive state is simply the current status of all the object's attributes, because attributes will have some values. So the object's attributes will contain the passive state. This can happen when system is initiated. Initially it will be idle. So it will have a passive state. And some other certain applications will not require active states. They will always remain in passive state. They might be data processing type of programs where states are not relevant. Events and states are not relevant. So then in that case, most of the objects or the classes will remain always in a passive state. But active state is the current state of an object as it undergoes a transformation. If a particular class is undergoing a state as a result of a particular signal or external stimuli or an event, then we will come to the active state. Active state is something which changes dynamically. So you can consider, suppose there is a player, you are making a video game. So you have identified the player as a class, as a key class. Then certain attributes like its current position, its orientation, these are attributes, these are more properties. So they are passive states. Initially it will have this, but later on what will happen, as and when some steps will happen with the system, as and when the user will interact with the system, then what will happen, it will move. The player will either be moving, or it could be injured, it could be trapped, it could be lost. So many things can happen, and it will happen based on certain conditions or certain stimuli or certain event. So that such kind of things are called active states, where the class or the object is moving from one type of state to another type of state. So always there has to be an event. There has to be an event to force the object to make the transition from one state to another. If it doesn't happen, the event doesn't come, then it will remain in the current state till it will wait for the event to change. So how are states of the system represented? So if we want to make the state diagram, we need to know how we will represent it. What is the standard we will follow to make the state diagram? So first of all, it will have a name. That is the first one. And it will also have an entry and an action. So actions are executed when the state enters or exits. So you will have a name and you will have so many actions. So each action could be an entry action. It can be a exit action. These are two special kind of actions. Then you can have so many other actions that are different in each of the states. So depending on the event that happens, and depending on the previous state, and depending on the condition that has happened, there will be some action. And these are normally represented by do words. So do this, do certain activity. Or actually when you do, it can also go to a substate of the machine. So we'll see some examples or some problems. How they are represented in UML? First of all, you have to make a rounded box. You have to make a rounded box like this, like an ellipse. And the name component will be in the top. And here all the actions will be there. And the transitions will be from one state to another state. You will have some arrows denoting which is the first state. This is state 1 and this is state 2. So there is a transition and the condition will be written here, this place. All the condition and the constants will be written here. Initial and final states will be indicated by circles. Just like in some other state places we have seen circles. So there will be a closed circle or it will be a like this for denoting the end. This will be the start. A system may have multiple final states. So always it will have one single start state, but depending on there may be some branching. Under certain conditions, this state may go somewhere, and certain conditions, and this match may go and end somewhere, and this branch may go and end somewhere else. So you will have multiple ends, but you will not have multiple start. You will have only a single start. So this is the example. Here is a login use case. So login use case is an example. So the user will be in different states. Initially the system will be idle. It will wait for a user to log in. And when the person will be logging in, he will be typing the password. So it will respond. It will request display enter password. When this person wants to log in, when the login message will come to the system, you think of this as an interface. So this one is you think that your class is interface, user interface. Okay. So user interface will be initially in the idle stage. And when the user will request for login, then it will ask for request for a typing password. So what it will go to another another state called typing password, where the user will enter the password. And then when it happens then it may go to another stage which will be called as working, because the password is there. So it will try to do something. Maybe it will first look at the whether the password is correct or not. Or if the password is correct, it will go to the application like that. Now what will happen here, you see I have written all the actions. So what are the actions? There is an entry action, there is one exit action. The entry, it will set the echo off, and in the exit it will set the echo on. And here it will get char. It will keep on getting the char and storing the char. That means it will accept all the characters that the user is typing. So subsequently, that is why I have written subsequent to this typing password, it can go to a working, here we have shown working, or it can be something else like a validate password or working an application, something like that. So depends. If it is correct, then it may go to here, or in intermediate you can have another one between this and this, which will be validate password. If it is validated, then it will go here. If it is not validated, then it will stop. It will come to the end. So let's look at this problem. You have a problem which is the access system. What is an access system? It allows you to enter into a building. So initially it is in the locked stage or an idle stage. At a pre-assigned time interval, it will keep reading the password entered by hitting the key by an external user. Just think of it. I don't know whether you have seen such kind of things. If when you go enter a building, there will be a small instrument in which a person has to enter his password, and then the door will open. Otherwise, it will not open. So that is what is this access system. It is a so it is expecting it has got a program which is expecting a password. Now when it gets the password, what it will do? It will compare the password. It will have a database of passwords. It will check whether this person is authorized or not. Only after comparing and if it is a wrong one, then it will ask enter again. So it will allow only a fixed number. Let's say 3. Let's say it will allow only 3 times, 3 number of trials. So this is another variable until it is correct. If it is correct, it is fine. If the password is valid within the number of trial limit, then it will go to selecting phase to give the access and then continue to get the next user input. If it is, that means it will go to the wait stage or the locked stage, and it will wait there till the next user. And if the number exceeds or still the password is not correct, then it will go back. It will not allow. It will just go back to the locked state. So here what we will say is that our access system instrument is the object that we have identified. It's the key object which is changing its states. So it has 3 or 4 states: locked, read, compare, select. And the events are that these things that we have seen, the conditions. Pre-assigned time is there. So whether it is exceeding the pre-assigned time or not. This is one event. Then characters are there to read. So once there is no character to read, then it goes to the checking of the comparing of the password. But till the characters are being read, it is in this stage. This is an event. So the number of trials, this is also another event. Then similarly, password validated, this is also another event. And what are the actions during when it is in a particular stage? When it is in one of these states, suppose there is a read stage, then it will have to get the characters. And when it is in compare stage, it will have to do the comparison. So these are some of the actions that will be there when it is within a particular stage. So now we have to draw the state. So you will get a problem like this, and you have to identify all these things, and then you have to go to draw the state. So you will have a see, this is the locked stage. Here the user is there. The user is entering the key. So when it is entering, initially it will be there in the locked stage, and at particular time interval it will come and keep checking what is entered. Okay, so that's why timer greater than lock time. And then when the password is entered complete, the reading is over, no more characters are there. Here the internal actions are not written. I'm sure you can do that work. You can complete it, whatever is not there. So here password is entered. So here you can see there are three compartments. This is kept for entry exit, and this is kept for the other actions. So there is a do action, validate password. The entry exit is not written. So here like that you have to keep the entry exit and you have to make it. So the password is correct, it goes to selecting. or otherwise it tries to see whether number of tries is greater than maximum tries. If it is less, then it will do a iteration there. And if it is selecting, if it is successful, then activation will become successful and the lock will open. So next we can take up the order management system. I think it will be a little easier for all of you because we are all familiar with this. So what is the problem statement? System will move out from an idle state when it receives a request for sending an order, and exits if the invalid request or any other abnormal condition. For a valid request, it responds back for selecting between normal and special type of order. It will then display the respective order format, whether it is either a special order or a normal order, and request the order input confirmation. So when the user has completed the order input, then it will give the confirmation. So the system will get the confirmation, and when getting the confirmation, the order will be generated. And it will move to the dispatch. It will get dispatched. The transaction will get completed and the system comes to the final state. So this is the problem statement that has been given to us. Now we have to draw this state diagram. So we will first identify the state. So there is an idle state. There is this sending order request, order type selection, order confirmation, order dispatch, and these are the messages or the events that will happen. Receive the order type, receive the request, receive the confirmation. And what will be the actions inside when it is in one of the states? You can say validate request, display order form. So from here you have to, from the description of the statement, you have to collect all these things. So now you can draw it, you can create the idle stage first. So this is the starting, and this is initial object is in idle stage. And this is the message is not written, so you can write it. I have knowingly kept some incomplete so that students will be motivated to complete it. So that intermediate state will come send order request, and it will come to select. So here action. So action will be the condition here for the transition, and then it will select the normal or the special order, and it will confirm the order, and it will dispatch, and then it will be complete. But if the order is if the request is not correct, or some abnormality will happen, the user may cancel it, he may want to get up or close, then it will come to an abrupt end. So like that you can create the state chart for any use case. Any use case will be given to you like that, or some problem statement. You can identify the states of the transitions. So what we have to note here, state diagram describes behavioral aspects of the system. Aim of the state diagram is to provide understanding of the algorithm involved in performing the method. So as you can see, we have gone into the details of what action it is doing. So basically it is telling you the algorithm. It depicts the states of objects. So whenever there is a dynamic change in the state, then in that condition we are telling the algorithms. So I was telling you that it is a dynamic, when the system is executing, when the objects are actually alive, that time we are trying to simulate that situation and create the states. And states of an object can be identified as condition. That all we have seen. So we'll go to the next slide. Okay, to complete the OO design, all activities within the state diagram must be assigned to objects, and all control flows are associated to links or relations in the object diagram. Now we will come to the second one, which is the sequence diagram. And we will try to see what and why of it. Then we will go to some problems and see how to draw it. So sequence diagram represents how events and messages cause flow from one object to another object to complete a function over a time period in sequence. This one is very important. So always we were trying to show the time, how the time progresses. As the time progresses, what are the messages being sent, what actions are being done by different objects, because these messages are going from one object to another object. It can be considered as a different view of the use case diagram that represents the objects of the key classes. Again, we are going to the key classes and the events that cause certain behavior to flow from one class to another class. So here that behavior, that flow is basically a message flow. This is the message flow. And the system objects and events flow will help in creation of the effective design. That is why we are doing it, because basically from the requirements we have to go to the design and the coding of the actual system. And once the classes are identified, either using the CRC method or the grammatical parsing, events have been identified by examining the use cases and the description. What the analyst will do, the analyst will start creating the sequence diagram. So this is, they will try to, even if you don't have a state, even if you don't have active states for a particular, but you will always have a sequence diagram. Sequence diagram is normally a must in every object-oriented system. So what are the terminologies, conventions, just like we had seen there, we will see here. So the first one is the object lifespan. Every object will have a life, and that life we call it lifeline. It shows the object's interaction during their active life and idle. So once the object is instantiated, until it is terminated, it will have a lifeline, and during that lifeline sometimes it will be active and sometimes it will be idle. Then there will be other lines which are called message lines. These message lines are indicating what is the message that is being exchanged and when it is being, because always we are talking of time and sequence. It consists of two dimensions. When we draw the sequence diagram, you will find that it has two dimensions. It has a time dimension, which is basically the exchange of messages, and it will vertical direction means the time. In the vertical direction, we will show the time dimension. That means the time will go from top to bottom. Time will progress from top to bottom. So this is the 0 time and this is the nth time. And horizontal direction will represent different objects that will interact. So you will have an object here, and here you will show the interaction between the objects. And this will be from left to right in a sequence. Messages are sent in sequence left to right between objects. A sequence diagram is an alternative way to understand the overall flow of control between objects in a software system. So this is why we need to create a sequence diagram to have a better understanding of how these objects that we will code, we will design and we will code, how do they interact. So this is an example. This is class 1. So always we are talking of the object here. We are not talking of the class. There we talked of the class. Here we are talking of that. So you can see how it is denoted. Normally, many times it is put a underline is put under the object to show that it is an object. It is not a class. That means it is an instance. Otherwise, you will have a this dot. So this is class 1. This is class 2. Another object. And this is an object of class 3. So this is your lifeline of the object. This is the class 2 object lifeline. Similarly, you will have object 3. So this is your time sequence. Time is moving here. So the first message is being sent to the object class 2, and under certain conditions, this message is being sent. If this condition doesn't happen, maybe another message will be sent. The return will always have a dashed line. And sometimes, since the object is instantiated, it has to be terminated or killed. So you will denote it by this kind of terminology. So this is another example. You have an actor. This is the external entity, a salesperson, and this is process order screen. We are not writing the name of the object. So this is the class. This is the interface class. This is the order screen. This is the items. This is the stock of the item. So some objects will be instantiated. So when here it is idle. So only when this item number will come from the screen, order screen, then this item will be checked whether it is a correct item or not in the item class. And then if it is there, then we will have a get quantity. So the stock will be checked. And otherwise it will come. So you can say that the use case is like this. The use case is an item query use case. Calls are solid lines. So these are the exchanges that is going, and returns are dashed lines, and messages and events are labeled. Diagram shows the normal message flow. There will be some exceptions, like suppose the item is not found, then there will be some other return here, like that. You have to write this, you have to write the message here. So not found, error, process order. So these kind of things will also have to come back. And all the time, if the message has gone from here, from this object, then it has to come back to that object. Okay. I hope it is clear to you all now. This is another one. Now here what we do, we are showing the destruction. We have already seen it in another slide. So that's quite clear, I think. It will create this object. This is A and this is B. So it's a construction of B is creating because some message has come. So B is instantiated, and this is its active lifeline, and some operations it will ask to do. A will request some operation from B and send the result, and then it will not require B anymore. So it will send a message for destroy. And you can have some timing denotation. Suppose there is some delay. Normally there will not be a delay. It is expected to be synchronous. But suppose there is some delay in real-time systems, you can show it by some slanted edges. Messages should not cross, otherwise there will be some race conditions. Sequence diagram problem, hotel reservation software. So this is the problem statement. A realtor is there. He is having a chain of hotels. Okay, I put it in italics. And he wants to develop a hotel reservation system. So you are the analyst for it, and you are reading this. The user will log in to the hotel chain's web site. So you are creating that website. You are creating the reservation system in the hotel chain's website, and it will request for making the reservation. Okay, so you have done it in so many other online webs. The system will transfer the request to the selected hotel, okay, and to do the processing, because the hotel chain has got many hotels. So depending on what is the place the person wants to travel, it will select the particular hotel. So the hotel will need to check availability of the rooms. Otherwise, it cannot do the reservation. So it will have to do the availability, and in its facility, it will have so many rooms. So it will check, and it has to check for each day, because the reservation request will have so many things. It will have the place, it will have the dates, from date to date, all those things, and type of room, and so many things. So it will have to check all those things as requested by the user. If the availability exists according to the request, then the system will send back a booking confirmation. Where it will send to the chain of hotels, because chain of hotels is holding the control. It is controlling the software. The user is logging to the chain of hotels. The website is belonging to the chain of hotels, and it will display to the user through that interface. If it is not, then it will have to send a regret message. Now we have to identify the objects class and do the sequence. So user interface, the boundary, this is the boundary object, user interface. Then hotel chain, which is a structure. You have seen that so many types of classes can be there. So structure is another class. It's a building. It's a type of organization. And hotel is another organization or a structure. And reservation is a process. So that is another class. And confirmation is an event or a message. So that is also another class. So messages condition will be login user, make reservation, and so on and so forth. So let's look at it, how it will be. So I have again, this is a little incomplete. So you people are required to draw the class diagram of these objects, complete the sequence diagram. So these are all the objects. As I told you, sometimes instead of the dot, you will put a underline. The underline denotes that this is a object. So a hotel is an object of the hotel class. A chain is an object in the hotel chain. There can be many hotel chains. So he is the user interface. So he can go to different hotel chains. So it will ask the it will send the make reservation. This is the message, and now you can see it is the way you will code it. So that is how it is written. You need not write it like this because this is the analysis. At the later stage, at the design stage, normally we put it like this, in the more like a code. So it will come from here to here, then to here, and here it will keep looking. It will go to the hotel. So the hotel will keep checking because he had to check the availability for each one. So here it is a boolean because a true or a false value will come. And if it is there, the condition is there, so it will keep this, and it will create a confirmation notice. If room is not available, then it will send a regret. That is not written here. So as you can see, and then at the end of it, this will get deleted. When all the messages will return back, the return messages are not there. They are not completed, and this part is not completed. Now we come to the third one, that is the collaboration diagram. In the collaboration diagram, shows similar information to sequence diagram. In fact, sometimes we make the sequence diagram and sometimes we make the collaboration diagram. If we are not interested in the time-based ordering, then we can go for the collaboration diagram. But if we are interested in the time-based ordering, then we have to go for the sequence diagram. So here what it will provide object links, solid lines between objects that interact. We will not show those dashed lines and this line. We will not have those arrows. It will just be lines. On the links are messages, arrow. And you can put some arrows if you want. If you want, it is optional. Arrows are optional. And the direction, just to show the direction. Most of the time, the direction is not depicted. Optionally, the message can be numbered. So if you want to make the collaboration diagram look more like a sequence diagram, then you can put the arrows and you can number it so that some order will come. Emphasis is on static links showing the collaboration between the objects to satisfy the functional objective. Okay. So collaboration diagram, what and why? Why should we do it? This part we have covered. Up to here we have covered. I was having some problem. It's easier to develop and help increasing the clarity of the. Always we are going to the more detail of the functionality in different ways. We are trying to see the behavior in different ways, and it is more understandable. Instead of a sequence diagram, looks like more like a technical diagram, whereas the collaboration diagram looks like a more user friendly, so the user can understand. And in UML 2.0 onwards, it is collaboration diagram has been stopped. It is now termed as the communication diagram. It's slightly in a different form, but earlier it used to be collaboration diagram. So if you see, this problem description is like this. There is a telephone system, or you can call it as an exchange. And so earlier days this used to happen. Shows the collaboration between telephone system and two users for a conversation. You can think of this as your mobile phone tower or something like that. And two mobile phone users are there. So user one takes the phone off the hook and on dial tone. So he gets a dial tone when he takes it off. He dials the desired number. Then the phone system, it will come here to the exchange. And the exchange, the phone system will send a signal to the to wherever it is, whatever number he has dialed. So this signal will go and it will create a ring to the user 2. Then the user 2 will receive and take the phone off the hook. And then what this one will do, it will establish a connection between these two, direct connection between these two, so that both of them can talk. So now this person can say hello. So you are here and your aunt is here. So you are making a hello. Now if it doesn't, the exception is not shown here. So if it doesn't, then it will send a message here saying that it is this call is not successful. So if you want to make a collaboration diagram, then you have to show the collaboration diagram. So that was one we have seen. Now let's think of another problem. You have a elevator. So you are making an elevator, and you have an elevator, you have a cabin inside it. So this is the system, and this is the cabin which has a door which opens. So you have to, in the elevator system, you have to go and press the switch, then the door will come to you, the cabin will come to you, and it will open the door, and then lights will turn on and you will go in, and then it will close. So that is what I have written here. It is the problem diagram. So then you have to identify the these classes, active states: elevator, switch, cabin door. So these are the states of the system, and these states will these are the these are the objects or the classes, and they will be interacting. How they will be interacting, and under what conditions they will be interacting. When they interact, what actions will happen. And optionally you can put this number: 1, 2, turn on light, and 3, close the door. So those things can happen. The cabin will go up and it will open the door, and it will turn the light, and it will close. Now this is what I have been telling you earlier also. These two are called collaboration, and sequence diagram is called interaction diagram. Both the diagram detail about the behavioral aspect of the way the objects are interacting. So what is the difference between these two? Sometimes this is a very important question that is asked in the interviews or in your examination. Sequence diagram is used to visualize the sequence of calls in the system, whereas here visualize the organization of the objects, how they are organized and how they are interact. So this is more about the organization, the structure of these different objects and how they are interacting. This is more about which is sending message to whom and in what sequence, what order they are sending. The sequence diagrams are used to represent sequence of messages, and this gives a structural organization. Sequence diagram is used when time sequence is the main focus, and this is used when the organization, the collaboration organization is the main focus. And here it can be used for small number of objects, but this is used for better suited to analysis activities, and it is better for your OO design. But here if you have a smaller number of activities, you need not go for a sequence diagram. You can go, but if you have many objects and you want to make the different types of collaboration between it, the message passing, then you have to go for the detailed sequence diagram. So this is just an example I could get from somewhere, where the same receiver call exchange receiver talk system is written in a more elaborate way in a collaboration diagram. So this is your collaboration, and the same one is written in terms of a sequence diagram. So here these are the objects: caller, exchanger, receiver, talk, and you have these off the hook. First it goes off the hook, and then in dial tone comes, and the dial number is dialed, ringtone is going to the receiver goes on the hook, and receiver goes off the hook. So again it is terminated. So this is the sequence diagram. Okay, so you can see this is the time domain. Time is going up from top to bottom. There is no time domain here. Absolutely, time is missing. The time is not important here. Whereas here the time is important. The time is important and sequences on the ordering. And we say sequence, that means in which order the messages are coming. But here it is optional. These arrows are optional. You need not give the arrows. And also these numbers are optional. Only dial tone, off hook, these things are important. This name of the message. But this one is not important. This is an extra information to show the ordering. Now we come to the fourth one, that is the activity diagramming. So what we have completed the state diagram, we have completed the collaboration diagram, and we have completed the sequence diagram. So now we will come to the last one in the behavioral diagrams or behavioral modeling, that is called activity diagram. And it is actually a user scenario. It's a user view for control of the business operation. Just like use case, we are showing the user's view. Similarly, activity diagram is not an interaction, but it is a user view. User view of what? Of a business operation. If you take a particular business operation and what are the activities involved in it, and if you create a control flow of all the activities, then you will get what is known as the activity diagram. That is the what is meaning of the activity diagram. It's created during requirement elaboration. Sometimes it is also created during inception or the next phase. And behavioral view that displays the activity flow. It's also a behavioral view because it is showing the activity flow of the business process. And it is more like a process flow chart. So we are familiar with the flowchart concept that we write the program, but there in our flowchart we write the statements, the program statements, and the control within it. Business process steps. What are the different steps that follow in a particular business process? So there can be two types of activity flow. You can have a simple activity flow, which looks very much like a flow chart. And you can have a swim lane activity flow where you will have different objects. And each object will have different, for the same operation, the responsibility will be distributed between different objects. But the operation is the single one. The distribution, the steps of the operation are distributed over different objects. So you need to create different objects and put them in different swim lanes. It will differentiate the operations of different objects, and it is normally depicted by a vertical flow between sliding vertical lines. So if you go to a swimming pool, what will happen? You have lines like this. If you have seen a swimming pool, you have swim lanes, and the swimmer is here. The swimmer is supposed to go here. Another swimmer is supposed to go here. So you can think this is your object 1 and this is your object 2. And each one is following their swim lanes. But they are all together doing a single operation, a business operation. This one is doing its role, this one doing another role, this one is doing another role. And somewhere they will come to synchronize. We'll see how they are synchronized, how they are related. So we'll look at some of the notations again. Similar to the state diagram, we told that time that this state diagram is like activity diagram. Now we are saying activity diagram is like state diagram. So you have a filled circle and a concentric circle, and you have branches. Just like in our flow chart, you have branches, you have guard conditions, and you have Boolean values. And this branching will be denoted by a diamond symbol, and it will decide the decision of the activity whenever there is a choice of branching, and all possible outcomes should appear on one of the outgoing branches. A simple activity diagram looks like a program flow chart or a control chart. So let's look at one of it. We will take it like a problem, so that if you get the problem, then you can make this. So in the problem activity flow of ordering process placing operation. So that time we did order processing. Now we are doing the order placing. Okay. So user will begin order entry and add item details one by one. At the end of all items, the system computes the total amount. So we'll come here, begin order. That is the first activity of the process, complete process. This is the start, the filled circle. And here we are going on adding. So there is an iteration here. Just like in program, we have an iteration here. Each iteration, we are adding an item. And if the item is over, then we will come out of it. And until and unless the items are over, we will be here. Then system prompts to confirm. It will calculate the total. At the end of all items, system will compute the total, and then it will ask, it will show, it will display after this, and it will ask the person whether you want to confirm. Think that you are buying your goods from Amazon or Flipkart. So you are adding items by item to your order, and then finally you will ask for the payment. So it will go and compute. It will show you the complete order, and it will ask you whether you want to confirm it so that it will take the payment. So like that. So here we are not talking of that. We are talking of a slightly different situation. If user confirms, then order will be placed. Okay. So once the order is placed, then executed. And that execution part is missing here. Each ellipse is an activity. Otherwise, if it doesn't confirm, so this is the no part, and this is the yes part. Similarly here, this is the yes part, and that is the no part. No, and this is the yes part. It will place order. Otherwise, it will cancel. Here also, you can show that the similar kind of situation, but now there are we want to show the exception situation. We want to show the out of stock situation for the item. That time we had a normal flow. Now we are having an exception flow. So the activity diagram from the exception flow. Business process will need multiple diagrams for different operational view. Multiple users, separate swim lanes have to be added for describing user-based operational view of the business process. So here, actually, this is slightly misplaced. So this we will come in the next slide. So here what happens, this is a special conditions instructions will be put. So order item form, select the item, select quantity. Now this is the normal one. This is the normal one. But sometimes it will go to out of stock. If the out of stock is there, then the error will be displayed. That is why the error form is coming. So here you have order item form. Here you have the customer. These two are part of the interface. This and this both. So here you are getting out of stock. Once it becomes out of stock, it will go out. This one we will deal with the next slide. So what is swim lane? So that is what I told a little earlier. So swim lane is a visual element used in activity diagrams or process flow diagrams to distinguish between responsibilities for sub-processes. So like in the last slide, I told you multiple diagrams for different operational view. So that is what, and multiple users for separate swim lanes. So you can have normal view, you can have exceptional view, and you can have multiple people doing it. Each one is supposed to do a sub process, and for that sub process they are responsible. They are not responsible for the full process. So many process modeling methodologies utilize the concept of swim lanes as a mechanism to organize activities. So swim lanes are not only used in software engineering, but they are normally used in many other business activities, business analysis activities. So what they help us is that they organize activities into separate visual categorization. So you can see these sub processes visually. So when you have something visually, it is very easy for you as an analyst to discuss with the user and get it confirmed. So the clarification of the requirements get much better when you have these visual tools. So different functional capabilities and responsibilities. Swim lanes may be arranged vertically or horizontally. So the what I showed you in the swimming pool is horizontal, but normally in when we do activity charts, we use the vertical manner. We make the swim lanes like this. So here the users will be here, one user, second user, and the activity flow will be here. So we'll take this problem. Draw the activity diagram of placing purchase order contract with swim lanes denoting customer, sales, contract, legal and fulfillment. So now this purchase order or the contract, now this is a much more, it is not just a sales order, but it is a contract. So therefore there are many more sub processes, there are many more entities or roles. So they are all different classes. Customer is one class. So there will be different objects for each class who will be doing part of this process. A customer will submit the purchase order to the sales representative. So customer is only interacting with the sales representative who enters it into the system. The contract department agent will review the order. So when sales department gets it, the contract department will be able to see it, view it. So one agent will come and review the order. What he will review, what he will do, if the terms, he will first look at the terms and conditions of the order. Okay, think of it that you are getting a contract for the development of a software. So you have placed a purchase order to the customer. So now the customer's agent contract department has taken it. They are looking at the terms and conditions that you have given, and their organization has got some standard, so they will compare it. If it is okay, then what they will do, they will approve the order and send it to the fulfillment section. To dispatch of goods, what is the dispatch of goods here? The goods is the contract here. Or if it is to supply something, then the goods will be done. But basically the contract is approved. But suppose it is different, then if order terms are not okay, then what will happen? They will send it to the legal department, because they do not have the authorization to approve it. Now the legal department will look at it. There will be some attorney or a lawyer in the legal department, and they will review the terms from the legal point of view, because there will be so many laws of the land, so they will have to check it. And if it is acceptable, it is not according to the organization standard terms, but it is acceptable, then the order will be returned to the contract department for processing. But suppose it is not acceptable, then they will return it for rejection. So this is our problem, that we have to create an activity diagram. So this is one process, so we have to show the sub processes. So you can see we have taken the customer, we have taken the sales representative, we have taken the contract agent, we have taken the attorney from the legal, and there is a fulfillment section who will basically process the order once it is approved. So that is what, so this is logging the error, then it is going. So these are the swim lanes. This is one swim lane, this is one swim lane, this is another swim lane, and like that. So it is flowing from one swim lane to another swim lane. And for each swim lane, there is a particular sub process. So again it will come back. It will go here and again it will come back. And if it is approved, then it will come here and it will be the order is shipped. Otherwise, it will come to the attorney. The attorney will, if it accepts, then it will go back to the contract department, and contract department it will again go. So finally, contract department will approve the order. This is only a kind of a advice that they will ask from the legal department. So I think the concept is now clear. Always there will be one start and it will come here, and either it will end here, or so there will be multiple paths. It can come here and then go, and like that it can come here, or it can come here and then come here, and is not notified, order is not shipped. Now we'll coming to the synchronization, because whenever there is a multiple sub operations, then there comes to the something that there may be some synchronization required, because different roles are doing sub processes. So sometimes they may have to join, synchronize, and they may have to branch again. So the branching is called as fork. Forking is represented by multiple arrows. So that is going out, and joining means controlling the concurrency and synchronizing it. So that is written as in the form of a synchronizing bar. So let's look at an example. So we'll take a problem to understand this, so that you will also know how to solve it. So you are taking an ATM. We are taking the example of an ATM. And what happens in the ATM is that you have a problem, you have a customer coming to the ATM. He will insert the debit card, then he will be prompted to enter the PIN. So he will enter the PIN, and if PIN is entered, then and it will go, the signal will go to the bank from the ATM, and the bank will check, the bank system will check the authentication against the account, whether that particular PIN is correct, whether he belongs to that particular PIN for the particular account is correct. If it is incorrect, then the card will be rejected. If the PIN is correct, then the user is allowed to continue with the transaction. So what the user will do, he will enter some amount. When he will enter some amount for withdrawal of money, then that balance has to be checked. So again, the signal has to go back to the bank, and the customer's account has to be checked. Then if the balance is okay, then the amount will be given. But sometimes it may be less. So then it will display a low balance message, and it will reject the card. It will eject it, actually, remove it. So then the customer has to take it out. Now, if the balance is available, then the message goes to the ATM machine to provide the cash. So many things will happen at the time. The ATM machine has to provide cash. At the same time, that much amount has to be, sorry, I think I should have written debited. Debited from the existing account balance, not credited, but it has to be removed. It has to be removed from the account balance, so it should be debited, because we are putting our debit card, existing account balance, and the new balance will be displayed. So earlier the balance was higher, now the balance is lesser because the money has been taken out. In either case, the card is ejected and when the transaction is complete. So if it is invalid, it is ejected. If the balance is less, it is ejected. If the transaction is complete, it is ejected. And then the customer can take out the ATM card. So now we are going to write the activity diagram. So we will make 3 swim lanes: customer, ATM machine, and bank. And it will start from the customer. Activity will start from the customer, and it will keep coming through the ATM machine to the to the bank, and it will get authorized. Then valid PIN, it will check. Then it will also check the balance. If it is valid, then it will ask for the entering of the amount, and it will check the balance. If balance is less, then it will go out. But if it is same, then it will come here. So here it has to fork. So at this point, it has to do 2 actions. It has to do this action, take money from the slot. That means it has to take physically it has to give the money in the slot. The customer will give, ATM machine will give that thing, and the bank will have to debit the account. And once these 2 are completed, these 2 will join in. When these 2 are over, that means the ATM machine has given the money to the customer, and the bank has also debited the account. These 2 processes have to join in. They have to be simultaneous. They have to synchronize. These 2 concurrent branches have to synchronize here, and they have to show the balance. And once this is done, then it will eject the card. And here there is a merge, because could be an invalid pin, so that will merge here. And this is the fork, this is the join of two different branches, and this is a merge from two different areas. It is coming. This is a special type of merge. Join is a special type of merge where it is a synchronization point. That is also a merging of two branch coming, but it is always denoted like this. This is denoted like a fork, and this is denoted like a synchronization bar. And then it will eject the card. So now you can do some more problems. I have written some more problems for you. You can create behavioral interaction diagrams for login to the system with user ID and password authentication. You can draw the state diagram. You can draw the activity diagram. Then you can take another problem, publishing a paper. So if you are an author, you are writing a paper, then you will have a role called as an author. Then there will be somebody who is a reviewer, like you are writing a project report, like that. Somebody will review it, check whether it is correct or not. So he'll give you some comments, and you have to incorporate the comments, and it will go to the publisher. So publisher has to publish it, and publisher will send it finally to the printer. So publisher will do some formatting and put some page numbers and some other things, ISBN number and everything. So this will, from a paper draft, it will become a published paper, and that published paper will go for the final printing, because this some printing machine it will be. And then what you have to do, this is the problem. This is the problem statement. And what you have to do, you have to show the activities in swim lanes. And you have to give this required synchronization, because these rules will be there. So before doing that, you also can identify the class object and draw the sequence diagram. So you can draw the activity diagram and you can draw the sequence diagram. So think that you are writing a system for a publication house. So there is a publication house which is requesting to authors to write papers. Authors are submitting, then it is sending it to the reviewers. The reviewer is submitting comments. Then it is doing its work. It is doing all the messaging, information exchange between these things. Who is doing it? Publisher is doing it. So publisher will have an editor who will do all those things, and then there will be a printer. Similarly, you can take up the very familiar college management system. So you can have so many roles: students, teachers, admin. So you can take them as classes or roles, and you can make swim lanes activities, and you can also draw the state diagram of the student, because student will have different states at different time. So you can think of that and write it. And if you do all this, then you will become experts in this kind of diagramming or doing the analysis of the software, so that you are ready for the design and the coding. So what we did in our class today, we discussed the behavioral modeling, constituent diagrams. We looked into the way to create state diagram, which depict the dynamic behavior of the system or its objects in response to certain events. Then we looked into sequence diagram. Sequence diagram was a different type of behavioral diagram, which shows the interaction between objects, and here the sequence or the time sequence was important. Then a little slightly different form of the sequence diagram, which is called collaboration diagram, where we are not going into the sequence or the ordering of the time of the messages, but we are only showing the collaboration, the structural collaboration, the organization of the objects with respect to the collaboration. So, and we noted the difference between the sequence diagram and the collaboration diagram. And we also discussed that these diagrams are now called as communication diagram. Finally, we discussed the activity diagram, which depicts the user's view of the business operation. It's a business. It is that's why in our first slide we showed it under the scenario analysis. So that is what we did, but it is definitely a behavior diagram as far as UML is concerned. And we added the concept of the swim lanes and the synchronization in the flow of the activities for an operation among the different roles in the activity. So we did a lot of problems, and I have given you a few more problems. I hope it is clear to you, and you should attempt more problems so that these things will become clearer and you will remember the concept. Through these problems, you will understand the concepts and you will be able to remember it better. So thank you all. Let me look at any question. I am not looking at any questions. I am not seeing any questions that is specific to this particular topic that we discussed today. So they are all general things. In any case, next class we will be discussing more on software engineering, and we'll possibly go to design because we have completed the requirements engineering as on today, all the modeling. So we will see how to do the design and the next phase of the software engineering. So if you want, you can go through these things and give me a you can ask the questions in the next class also. So thank you all, and have a good night.